welcome Valeria to the stage. You can put your mic and your camera on to join us.
Yes. Hello, Malika. Hi.
Thank you. Excited to hear about your presentation. Thank you for taking time. I think you can try to share your screen before I leave the floor.
Yes, of course. Okay, so I think you can see my screen now.
Yes, I can see. Yes, perfect. Yeah, so perfect. Valeria will tell you more about her before starting a presentation. You want to share again?
Yes. Okay.
Yeah, now
it's better.
Okay.
Yes, thank you again, and I'm very happy to be here in this amazing event. So 3 days full of interesting presentation and panel discussion. And I'm very happy to share my experience and the journey of my company Hydro into additive manufacturing. And I hope to give some inspiration also to the public and some case studies that we experimented in the past months and past years. So thank you again for the invitation. So I will start where we are. So we are based in Italy, in the north part of Italy, not far from Milano, but in a very green area, as you can see. And I can say that also the nature that surrounded us can inspire us to create a new product with additive manufacturing. I really believe that additive manufacturing is a sustainable technology, and you will see during my presentation some examples and some also analysis that we have made. And again, maybe thanks also to the nice view that we have from the company. So a short history about Hydro. It was founded by my father almost 40 years ago. And exactly this year, we celebrate our 4th anniversary. Hydro is an hydraulic specialist company. And as I said, the headquarters is in the north part of Italy. And I started to join the company was 10 years ago now as a CEO. And 5 years ago, we discovered additive manufacturing. I was really amazed by this technology, and we decided to invest in metal additive manufacturing, creating a dedicated department in-house alongside the conventional manufacturing of hydraulics components. As I said, we design and produce hydraulics components like valve, manifold, and heat exchangers, both in traditional manufacturing and also in additive manufacturing. When we started the journey into additive manufacturing, we also decided to invest in the the quality management systems. Now we are certified AN 9100. And we also are member of standard group like ASTM, DNV, or API for the oil and gas industry. And last year, just a few months ago, we joined Desto Metal Group. This was really an amazing event for the company. We are really proud to be selected by Desto Metal to become part of this new ecosystems that they are creating. As you can see, this even if we are a little bit far from the US, now we have very large ecosystems within the group, and we started to evaluate, to make new research with the idea to boost additive manufacturing to the higher level, to the mass production level. And you will see some example of this very interesting journey. But what we can do, what we do, as I said, we do design and production of conventional hydraulics. You can see here some example. This is a really conventional manufacturing process. So from CNC, casting, we do all the process for the creation of hydraulics parts. And of course, we do testing and post-processing. Alongside this conventional business, we have additive manufacturing, in particular metal additive manufacturing, where we start from the design, and especially the design for additive. And we have some printers in-house, both with laser power bed fusion technology and with binder jetting. when we introduced additive manufacturing in our company, we were really disrupted by this new technology, because it's a completely new mindset. And we think that the idea that additive manufacturing can produce parts that were not possible before, or maybe were too complex, it's really amazing, because we are able to create parts and also solve some technical issues that were not possible with conventional manufacturing. So the design for additive is one of the best parts that really helped us to change our mentality and to start with a new approach. This was a quite, say, hard journey to change the mentality, especially for designers or technical people that were used for many, many years to do always the same mechanical design or mechanical performance. The idea, as you know, additive is to add material only where it is needed, and it's really very, very interesting. And thanks to topology optimization, we are able to reach very light parts with high performance. But again, what we do in-house is the design for additive. Sometimes we start from conventional hydraulics part and we rethink the part with the new mentality. And thanks to topology optimization and with the support of different software, our engineers are able to create parts that are really, but with high performance, and it can fit exactly in the systems, sometimes also with some strange shape or unconventional shapes. I'd like to share one of the main benefits that we found in additive manufacturing. So in hydraulics, we use a lot of channels. Inside the channels, we have oil in the pressure. And in the conventional manufacturing, we have to perform the drilling to make two 90-degree angles. You can see in this example. While with 3D printing, we are able to create a curved channel without any auxiliary holes, and we are able to eliminate the two pressure drops that are in the conventional manufacturing. So the first example that I'd like to show is one, for me, of the best hydraulic manifold that we have designed, because it's a very special application, and the conventional manifold that you can see was made in aluminum. The weight was 5 kilos, and the aim was to reduce the weight as much as possible, because the final application required a very lightweight component, because it's a portable power unit. So it's a tool that is handled by humans. So less weight means less cost of handling. And thanks to the design for additive, we were able to reduce the weight by 75%. This is really amazing and impressive. And we keep the same material, so aluminum, and we tested in the test bench the manifold. And what is really amazing is that with a good design for additive and adding material where it is needed, so in the channel where there is a high pressure at 10,000 psi, the manifold works fine without any failure and without any problem. So this is one of the main and the best part that because it's really disrupting for the hydraulics. Another good example is the possibility to integrate multiple components into one. This is a conventional manifold, and as you can see, this is composed by the assembling of the main plates and 3 valves on the top. With additive manufacturing, the possibility to redesign, we are able to integrate the 4 components into one and have only one part. So this means a lot of benefit in the hydraulic sector, because we reduce, of course, the weight, 60% of weight reduction, but the possibility to integrate 4 components into one, this means a saving in the supply chain, in the assembling time, And also we avoid completely the potential leakage from the assembling from auxiliary caps, plug, O-rings. So the benefit in this case is not only the weight reduction, but also the saving in the lead time and the better performance of the final manifolds. Another case is about heat exchanger. Again, I like to show some different products that we normally produce with additive manufacturing. And also in this case, what is really interesting is the possibility to create the shape as required by the application and by the systems where the heat exchanger is installed. In this case, is a heat exchanger for electric battery for a Formula car, particularly a student Formula car, where the shape of the heat exchanger is perfectly fitting in the battery and inside the systems. So another example of the flexibility that additive manufacturing gives us is to create exactly the shape and the parts fitting inside the systems. And now another point that I really like to underline is the sustainability aspect of additive manufacturing. Of course, we say that we add material only where it is needed. And so this means use less material in the parts that we produce. And thanks to topology optimization, we are really able to create the parts using the minimal of material that is needed for the performance of the parts. And another example coming here from our world, so it's a conventional manifold, so it's a hydraulic manifold, and this is the conventional parts made by the assembly of two manifolds. The bigger one is the gray one, and on the top in gold you can see the small manifold. So this is the conventional parts made by casting and machining. Thanks to the topology optimization and the redesign for additive manufacturing, we were able to create unique manifolds. This is the combination of the two parts into one, as you can see. And thanks to topology optimization, we reduced the weight of the parts. This was a project made with CNH because the application is in the agricultural tractor. And we tested these manifolds, again in aluminum, at 1 million cycles in the test bench. And again, the results are really, really interesting because there were no failure, no defects in the performance during the test. So we can say that additive manufacturing is a very good technology also for the, say, special application where the fatigue resistance is really important. Again, weight reduction means less energy consumption, especially for mobile machinery, like agricultural tractor, because to move the machine, we need less energy. The combination of two parts into one means less supply chain, so saving of time, saving of assembling time, and the benefits of avoiding potential leakage from the connection, and 70% less in lead time. This is another very, very interesting point, especially for the development of new products and for the spare parts. But the other point that I'd like to underline is the CO2 impact. As you can see, we can say we performed an LCA, so a life cycle assessment on this, and we compared the conventional manifolds, so made by casting and machining, a manifold with the same shape as the conventional one, but using 3D printing, so same weight, but with another technology, and the 3D printed optimized manifold. So the combination of two manifolds into one with 35 weight reduction. And as you can see, from the global warming potential point of view, so the kilogram of CO2 equivalent over 100 here, we have a reduction of 60% comparing the conventional manufacturing to the 3D printing with design optimization. Again, we have some assumption under this analysis, but the message is really clear. So thanks to additive manufacturing, we are able to reduce the CO2 equivalence and to have a more sustainable parts. But to do everything that you have seen, we have our internal department. We, as I said at the beginning, we decided a few years ago to integrate additive manufacturing in our company alongside the conventional manufacturing of hydraulics components. And we have all the different phases of the process. So from the powder handling or the raw material management, the design, the 3D printing using different technology of metal 3D printing. Now we have laser power bed fusion and binder jet. We have all the post-processing from support removal, where the technology requires support, but also the machining, testing, post-processing, heat treatment if required, and we take care about our the operators to have a very high level of safety procedures. We create our roadmap to additive manufacturing, and I like to describe you what we experienced in these 5 years. So from the investment in the technology, we really disrupted the company. The additive manufacturing entered in our daily life, daily working life, but not only in the work, also at home we have some 3D printing parts. And we completely changed our company. The mentality was really to welcome the new technology. And not only the technology, because we had a new quality management system, so EN 9100. We started with a new sustainability policy, thanks also to the fact that additive manufacturing brings some sustainable process. We had many partnerships with printer producer and with external partners, and we started to boost and promote the use of the technology, also helping the standardization and the guideline in different sectors. And from hydraulics, we started to work also in oil and gas and aerospace. And just a few weeks ago, we received the Leonardo helicopters qualifications, so for the aerospace sectors. And from September 2021, we are part of the Desktop Metal. So for the future, what we really see is to promote additive manufacturing, help this technology to become a real mass production of customization parts. And now some example of high volume production, because many times we ask ourselves or our customer ask if additive manufacturing is really a profitable technology for high volume production. I can say the reply is it depends, of course. It depends from many points of view. We are used to have high volume production from our hydraulics conventional manufacturing. Here you have an example of hydraulics blocks, and you see that normally we produce I say millions of parts of hydraulics component per year with the conventional manufacturing. But more and more we see some problem in the supply chain as all the other sectors. In hydraulics especially, we see a lot of delay from suppliers of parts, raw materials, and we can see that hydraulics are used in all the sector where there is a need of power to move a machine from mobile machine, but also to industrial machinery. So the hydraulic sector is facing a really critical moment due to the delay and the problem in the supply chain. So this could be a very good moment also to boost additive manufacturing for hydraulics. because to have this supply chain delay, it means loss of sales. And of course, many sectors and many customers are not happy about loss of sales due to the missing of products. And also the missing of the supply chain means a delay in the development of new products. So the new prototypes and the time to market became a very long time. So again, what we see that at the moment there is lost in time to market due to the missing of supply chain, from casting to raw material and foundry, and you can see that there is everywhere some conflicts, some problem in the supply chain. So the time became one of the main important aspects of today. And I want to share one of our 3D printed watch made together with Materia Giunta, a new design, just to give you the idea that time is really important factor today. So taking into account this main aspect, what we can see now that for additive manufacturing in the hydraulic sectors, we have many benefits, from the less weeks that are needed to produce a part in additive manufacturing, and this will help the development of new parts and new products. The benefit of to have lightweight parts means the use of less material, less raw material compared to the conventional manufacturing. The possibility to integrate multiple parts into one means a reduction of the supply chain, because we just have one supplier of 3D printed parts instead of multiple suppliers. And of course, we reduce the lead time and the time to market of the parts. And thanks to design optimization, we are able to reach a lot of benefit on the performance of the parts. So I like to share this example. Maybe you can see also I have the real part. I hope you can see it. This is a C-top valve, hydraulics valve, designed for 3D printing. So the conventional parts is more with the standard shapes and it's heavier. While with 3D printing, we are able to reduce the weight of this part and to have a faster production compared to the conventional casted parts. This is an example of the full platform for the laser power bed fusion technology, where we are able to produce high volume of hydraulics valve. Of course, after the 3D printing, there is a post-processing, in particular the CNC machining, but thanks to the design for additive, we are able to add extra material compared to the conventional manufacturing. So we have also a benefit in the machining of these parts, because we have less material to remove, and it will be removed only in the cavities where we need a good coupling between the holes. And another nice aspect of this valve that we call AMES, hydraulics valve, is the sustainability impact. Also on this part, we performed the life cycle assessment and we have very interesting results. As you can see, we compared the conventional manufactured valves with the 3D printed and redesigned parts, and you can see in the middle the big CO2 emission reduction, but also we 3D printed the valve with the green powder made by the startup, the Italian startup Fenice. And thanks to the fact that also this green powder is coming from the recycling of old parts, we have another big reduction of CO2 emission. And we are speaking about 80% of CO2 emission reduction. And now just some idea about the mass production. So what we are doing now. As I say, we received the binder jetting machine just a few months ago, thanks to joining the Gestometal group. And we see that binder jetting is really enabling for mass production. Okay, this is the first training that we had in-house, and the first part. Again, here, this example, this is a spool. This is a component that we use in our valves, in the hydraulics valves. In the conventional manufacturing, this spool is made by 3 components, while with additive manufacturing, we are able to make just one single part. We save a lot of time, thanks to the fact that we completely avoid the assembling. We received a very good results in terms of results, mechanical results. And also we are able to have less post-process, because again, we add material only where it is needed. And we are thinking about the benefit in the digital inventory for the future, when we will need some spare parts. And this is the mass production that we will see for the future. Thanks to new machinery, new printers that are on the market, we will be able to make thousands of parts compared to the conventional production. And you can see here a simulation. And the main interesting point is that the price of this small component will be half compared to the conventional manufacturing. So I'm very happy to have shared my experience, and I hope you enjoyed the presentation. And I want to leave you with this idea. So we have to think about mass production for specific parts, for specific design, using the good technology. But I'm really convinced that additive manufacturing will have a very nice future. So thank you very much for your time.
Thank you, Valeria, for your presentation on AM from niche to mass production, walking through your company. Congratulations for the anniversary. We have a few questions here to go through. We still have 3 minutes if you can answer some questions. What do you think right now is the biggest challenge in scaling your metal additive business?
Yes, for sure, is the idea to find the good parts, the good geometry, because not all the parts can be profitable with 3D printing. Maybe are possible from a technological point of view, but to find a good balance between the mass production and the geometry, we need to make some analysis, some tests, of course, and find the best part that can be mass produced with additive manufacturing.
Oh, thank you. Another question says, which sectors are more restrictive in terms of qualification, certification of parts from your point of view?
Yes, as I said, we work in hydraulics and also in oil and gas and aerospace. So the second two are more restrictive. Indeed, we joined some groups to create the guideline and the standard for the certification, and we adopted also this level of quality in-house. So I think that aerospace and oil and gas are both restrictive compared to hydraulics.
Follow up to that one, they said you mentioned those fields are very restrictive. How did you manage in your company?
We joined the group that created the standard and the guidelines. So we really contributed to the creation of the standard based on our experience and, of course, on the sharing with other people. And we decided to adopt, of course, it takes a new mentality, especially in the operators and the engineers who work with additive manufacturing, to follow all the procedure. But at the end, I can say that it's really a successful activities. Sorry, Malika, I cannot hear you. Maybe.
Thank you, Valeria. Just last question before we wrap up our presentation. Sabrine says, for the hydraulic manifold that did not fail at 10 to 6 cycle, is it possible to know if the results were repeatable and guaranteed?
Yes, yes, of course, because we tested the manifold in the test bench that are really used for the final application. So we see, and we have, say, approval from the end customers that the 3D printing is a repeatable technology, and also using the same process, same parameters of printing and same raw material, of course. So starting from the same main point, we can see that the process is repeatable and the results are exactly the same as the first part.
Okay, that's wonderful. So we have more other questions, but unfortunately we don't have enough time. I will copy those questions at the chat box for you, Valeria. If you can address them for our attendees, that would be wonderful. And thanks again for your presentation and walking us through your company and your activities toward mass production for additive manufacturing. We're excited to have you. Thank you.